Welcome back to another video. In this tutorial, we are going to look at how we can derive the quadratic function from roots. Okay, so let's look at how we can handle this particular topic. Okay, so basically, if you want to derive the quadratic function from a root, then you have to assume, or you have to let some variables represent something. Okay, so let's say that, for instance, let's say that x equals x1 and another x equals x2 be the root of the quadratic function. Okay, so we are assuming that let x equals x1 and x equals x2 be the root of the quadratic function ax squared plus bx plus c equals 0. Okay, so we have this preamble. Now, this quadratic function we have right here, ax squared plus bx plus c equals 0. This, because we want to derive the function from the root, we have to make sure that the coefficient of x squared over here is unity, meaning it's 1. So what we do here is that we factor a out. Okay, we factor a out just like we have here. So a out x squared plus b over x plus c over a. Okay, so that is equal to 0. Okay, so that is what we have here. Okay, so let's name this equation 1. You know, when you factor something out, it means you are dividing by the item. Okay, so that is what we have here. So when you factor a out, meaning you are dividing the coefficient of x squared by each of the items in the brackets. Okay, so you see, when you multiply back, you're going to have the same thing again. Okay, so that will remain the function as it is. We are not interested in changing the function. We just want to manipulate it so that we can have a unity at the coefficient of x squared. So that is what we have here. So now, this equation we have right here, this equation is equivalent to when we say that x minus x1, okay, times x minus x2 is equal to 0. This equation is equivalent to this. Okay, this is obtained from the assumption we made here. You know that if you say that x equals x1, then it means that you can have x minus what? X1. Okay, so basically we have this from here. Okay, so from here, we can expand this bracket, right? So when we expand that, we're going to have x squared minus x2 minus x1 plus x1 x2, and that is equal to 0. Okay, so let's write this here. So x squared minus x1 x2 x2 minus x1 x plus x1 x2, and that is equal to 0. But from here we can see that we have common terms, right? x2 minus x1 x. So we can factor x out to have x1 and x2 inside a bracket, right? So here we have x squared minus x1 plus x2 multiplied by x, right? So when we expand this, we get back to this, right? Plus x1, x2 equals 0. So we equate this to as equation 2. So this equation and this equation have something in common, right? So here we compare equation 2 with equation 1 or equation 1 with equation 2. So whichever way, comparing equation 1 and 2, comparing equation 1 and 2, we can see that a into, from equation 1, a into s squared plus b over ax plus c over a equals 0, right? This is equation 1. So we are comparing equation 1 with equation 2. So from here, you can see clearly that looking at the coefficient, you can see that the coefficient of x here is b over a. So we have b over a, right? And that is equal to the coefficient of x here is also negative into x1 plus x2, right? So this, we can say that x1 plus x2 is equal to negative b over a. So this is what we call the sum of roots. This is the sum of roots. Okay. Now, when we compare the coefficient of, we compare the constant, right? Comparing the constant, we can see that we have c over a equals x1, x2, x1, s2, right? So we name that as the product of roots. So this is the sum of roots and this is the product of roots. So for instance, if you are given an equation, okay, and you are asked to find the products, the sum of roots and the product of roots, basically this is the shortcut. This is objective wise. Okay, objective wise, this is how you do it. X1 plus x2 is equal to negative b over a, and product of root is x1 s2 equals c over a. So if you know this and you have to find the sum of root or the product of root, just have to compare the equation that you have been given to the original quadratic equation. Okay, so once you do that, you obtain the values of a, b, and c. Good. So once you have those values, you just come and substitute, then you have your sum of roots. So this is sum of roots, and this is product of roots, So that is basically how we obtain the product of root and sum of root. Okay, now let's look at how we can obtain the equation, okay, the quadratic function, the equation of the quadratic function, okay, from root, the equation of the quadratic function from root. So from here, from this deduction, we can say that see, we have a out, s squared plus b over ax plus c over a equals 0, right? So to obtain the equation of the quadratic function from roots, okay, then we just substitute what we have here. You can see that our b over a is here, right? And our c over a is also here. So we substitute this in place of this, and then this in place of that, to have the equation of the quadratic function obtained from roots. Okay, so the quadratic function obtained from root is giving us is giving us s squared plus b over a is here, right? As negative x, negative into x1 plus x2, right? So we have negative into x1 plus x2, right? Multiplied by x plus our c over a is here as x1, x2, right? That should be equal to 0, right? So we just do substitution from the formulas that we obtain to get our equation of the quadratic function from root. Okay, so this is what we have now. So this, when we expand or we spread the a again, we are going to have a s squared minus a into x1 plus x2 x plus a x1 x2, and that is equal to 0. So this is how you find the equation of the quadratic function given the root, right? So the quadratic function is given as this. The quadratic function is given as this. Okay, so therefore, or thus the quadratic function is obtained above, right? So that is the quadratic function derived from root. That is interesting. Now let's look at an example to clarify this problem. We have to find a quadratic function whose zeros are 1 plus or minus square root of 5 all over 2. So this is just a question, and we are interested in the quadratic function whose zeros have been given here. Okay, so this is going to be, as we did for the proof, let x equals x1 and x again equals x2, right? So these parameters you have here, you are going to associate them with this argument, right? So our x1 here is going to be 1 plus square root of 5 over 2, and our x2 will be equal to 1 minus square root of 5 over 2. That is interesting. Don't forget that they give us 1 plus or minus square root of 5 over 2. So plus or minus meaning we have positive within it and we have negative within it. So that is what basically we have done. Now, we want to find the sum. We have to find the sum of this. We have to find the product of this root before we can find the quadratic function. Okay, so the sum of these roots, now we know the formula, right? We know that x1 plus x2 is equal to negative b over a, right? Negative b over a. But do we have negative b over a here? Can we have our b and can we have our a here? No. So what do we do? This is just sum. Okay, so this here we have been given the everything directly, right? So here we don't need b over a. Okay, so this is how we go by it. x1 plus x2 will be equal to root of 1 plus square root of 5 over 2 plus 1 minus square root of 5 over 2. Okay, so that is going to be 1 plus square root of 5 plus 1 minus square root of 5 all over 2, right? You know, when you find the LCM for that, this is what you're going to have. So this takes off this, and you're going to have 1 plus 1 over 2. So that is basically the sum. So the sum of these zeros are x1 plus x2 equals 2 over 2, and that is equal to positive 1, right? Now we have the sum, so we have to find the product, right? So the product of these roots, right, is x1 times x2 equals, we are going to find the product of this x1 and x2. So we have 1 plus square root of 5 over 2 multiplied by 1 minus square root of 5 over 2, right? So here we expand that, we're going to have 1 then minus root of 5 plus root of 5 minus 5, right? All over 4, right? 2 times 2, 4, right? So we have x1, x2 equals, this takes off this, so we have 1 minus 5 over 4, and that is negative 4 over 4. So we have basically negative 1 for the product, right? So for the product, we have negative 1 for the product. So we have the sum and the product. So that is going to be ax squared minus a into x1 plus x2 x plus x1 ax1 x2 equals 0. So we know this formula, right? That is the quadratic function in terms of roots. So here we know that x1 plus x2 equals negative b over a, right? And over here we know that our a is basically going to be 1, because from here we know that a has to be unity. Okay, so we have our b, we have negative 1 here, right? So this means that our a is equal to 1, right? So that is it for this. Now let's look at how the quadratic function is going to be. Let's look at how the quadratic function is going to be. So we're going to have x squared minus into 1 times x plus 1 into negative 1 equals 0. Okay, so that is the process. That is basically the process that we go through to find the quadratic function given the zeros. Okay, ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates on this topic. Bye-bye.